What is a lithium-ion battery and how does it work? The lithium-ion, Li-ion, battery is the predominant commercial form of rechargeable battery, widely used in portable electronics and electrified transportation. The rechargeable battery was invented in 1859 with a lead-acid chemistry that is still used in car batteries that start internal combustion engines, while the research underpinning the Li-ion battery was published in the 1970s and the first commercial Li-ion cell was made available in 1991. In 2019, John B. Goodenough, M. Stanley Whittingham, and Akira Yoshino received the Nobel Prize in Chemistry for their contributions to the development of the modern Li-ion battery. During a discharge cycle, lithium atoms in the anode are ionized and separated from their electrons. The lithium ions move from the anode and pass through the electrolyte until they reach the cathode, where they recombine with their electrons and electrically neutralize. The lithium ions are small enough to be able to move through a micropermeable separator between the anode and cathode. In part because of lithium's small atomic weight and radius, third only to hydrogen and helium, Li-ion batteries are capable of having a very high voltage and charge storage per unit mass and unit volume. Li-ion batteries can use a number of different materials as electrodes. The most common combination is that of lithium cobalt oxide, cathode, and graphite, anode, which is used in commercial portable electronic devices such as cell phones and laptops. Other common cathode materials include lithium manganese oxide, used in hybrid electric and electric automobiles, and lithium iron phosphate. Li-ion batteries typically use ether, a class of organic compounds, as an electrolyte. Lithium ions are stored within graphite anodes through a mechanism known as intercalation, in which the ions are physically inserted between the 2D layers of graphene that make up bulk graphite. The size of the ions relative to the layered carbon lattice means that graphite anodes are not physically warped by charging or discharging, and the strength of the carbon-carbon bonds relative to the weak interactions between the Li ions and the electrical charge of the anode make the insertion reaction highly reversible. What are some advantages of Li-ion batteries? Compared to other high-quality rechargeable battery technologies, nickel-cadmium, nickel metal hydride, or lead-acid, Li-ion batteries have a number of advantages. They have one of the highest energy densities of any commercial battery technology, approaching 300 watt-hours per kilogram, Wh/kg, compared to roughly 75 Wh/kg for alternative technologies. In addition, Li-ion cells can deliver up to 3.6 volts, 1.5 to 3 times the voltage of alternatives, which makes them suitable for high-power applications like transportation. Li-ion batteries are comparatively low maintenance and do not require scheduled cycling to maintain their battery life. Li-ion batteries have no memory effect, a detrimental process where repeated partial discharge/charge cycles can cause a battery to remember a lower capacity. Li-ion batteries also have a low self-discharge rate of around 1.5 to 2% per month, and do not contain toxic lead or cadmium. High energy densities and long lifespans have made Li-ion batteries the market leader in portable electronic devices and electrified transportation, including electric vehicles, EVs, like the Nissan Leaf and the Tesla Model S, as well as the hybrid electric Boeing 787. In terms of decarbonizing our economy's energy use, Li-ion technology has its greatest potential in EVs and electrified aviation.